viewers, welcome to Digital School. My name is Pankaj Singh, Faculty of IT Department. Today I will deliver my video lecture on a subject Computer Organization and Architecture, and I took the topic Addressing Mode. It is the topic of first units. So let's start. Here these are the outline of my today's video lecture recording. And the topic which I will discuss here, that is addressing mode. After that, their types and the syntax we are using with the help of a suitable example, right? So now take a brief definition. What is addressing mode? Generally, addressing mode is used by a processor to fetch the address or to fetch the data from the memory or register. And as we know, in a computer organization and architecture, there are two terminologies generally used when we solve any expression. One is operand and second one is operator. So before going to all these things, first read few things about the addressing mode. Operands can be placed either in any one of the processor, that may be placed in a register or maybe in a memory location. To fetch the operand from the memory location or register, there are different methods. So these different methods we'll discuss in a next slide with their names. And if we talk about what is the basic meaning of addressing mode, the way in which the operand is taken from register or memory is named as addressing mode. So hopefully it is very clear to the viewers what is addressing mode. So to fetch the address or content from the memory or register location, we are using different addressing mode. If we talk in a broad, there are two type of addressing mode. One is direct and second one is indirect. In direct addressing mode, we are talk about the content, not address. There are different methods like direct addressing mode, register mode, immediate mode. These are the type of direct addressing mode. And in indirect addressing mode, we are using a simple mathematical calculation to find out the effective address of the content where it is stored. So in this method, effective address is find out using simple calculation. This calculation described in a format of the different addressing mode. So here I discuss one of the term, effective addressing. What is effective addressing? Effective addressing is nothing but that is the address where the content is stored, and effective address may be in a register or at a memory location. So I told in a previous slide that in a addressing mode we talk about two terms, operand and operator. If we take a simple expression here, x tends to a plus b, right? So it is a destination and these are the expression that will be solved. So here a and b are operand and plus is a operator, right? So we require some space in a register to store the value of a and to store the value of b. For example, a consists 10 and b consists 20. So the value of a is stored in a register R1 and the value of b is stored in a R2. And the concerned operation or opcode is performed by the help of ALU. So the now concern is arise how to collect the value of R1 from the register and how to retrieve the value of R2. For that, processor use different addressing mode methods. For example, there are two methods to call a person. One is directly, like if I call anyone like Ram, come to my cabin, that is the direct calling. And if I say to a third person and told him that inform to Ram and he will come to my cabin at 12 o'clock, that is the indirect method. I use some interface or intermediate to convey my information. So likewise, that is a basic difference between direct addressing and indirect addressing mode. So the value of R1 and R2 is stored in a different registers, and the methods generally used by direct or indirect. And further, it is also classified into different types. So addressing mode specify a rule for interpreting and modify the address field of the instruction before the operand is actually referred. Computer use the addressing mode techniques for the purpose of accommodating one or both of the following provision. So why we are using addressing mode different methods? There are two broadly reasons. What are these reasons? First one, we need a specific some set of rules to specify or to call a address, like specify a rule for interpreting or modifying the address field of the instruction before the operand is actually referred. So as we know in computer, each and every operations follow some set of rules. So when we call any address from the register or maybe in a memory, we use some set of rules, and in a addressing method we are following all these things. And secondly, it also helpful to give programming flexibility to the user to use the bit in the addressing field of the instruction efficiently. So it also gives the flexibility to the programmer how to use the address of the destination where the operand is stored. So these are basically both reasons that also make important of the addressing mode. Here in this slide we have different names of the addressing mode. First one is immediate addressing mode, second one is register addressing mode, third register indirect addressing mode, direct addressing mode, indirect addressing mode, implied addressing mode, relative addressing mode, index addressing mode, base register addressing mode, auto increment and auto decrement mode. Mostly mode have the same role, or we can say the same working as their name define. Here we have a immediate addressing mode. So we will discuss in a detail with their syntax as we go to their slide, but in a brief I give you a overview what exactly this mode will do when we specify address by using immediate addressing mode, in register addressing mode, or in a indirect addressing mode. The final conclusion or the final work will be the same, but the representation of this addressing mode will be different. So now let us start with the first addressing mode. So there is a basic mechanism how to call the address. We use instruction formats. It consists opcode, destination and source. That is the instruction format. We require these three fields when we call any address. If we go into an instruction format, it is of four types: 3 address instruction format, 2 address instruction format, 1 address in instruction format, and 0 address instruction format. In 0 address we use stack, in 1 address we use accumulator, and in 2 address and 3 address we use GPR, General Purpose Register. So it's another topic we will take in a next video lecture. It is a detailed topic, but I here give you overview about what is instruction format. So these are the field in 3 addressing field. Instruction format, there are 1 destination and 2 source. In a 2 address field, 1 destination, 1 source. In 1 addressing field, there is only 1 field that will be used for the source and destination. And in a 0 addressing format, we have no destination or source field. We have only the operation field. In stack is the example of 0 addressing format. So now come back to the topic of addressing mode. So when we define a address of any operand, we use this format. So how it will define here? If for example I write it here like add R B. So what it represent? It represent, or if we take it move, so it will represent like move is the opcode, R is the destination, and B is the source. So when we represent it, so the meaning will be R1 will contain the value of B. As we know, the left value will store the value of the right given variable, and operation is move, that is separated by colon in a RTL, register transfer language. So that is the basically representation of a address in a instruction format. So there are different methods to define the address in a different addressing mode. So now discuss one by one with their syntax. First we have type of addressing mode. We discuss direct addressing mode. I will go through the important points. Just like instruction specify the memory address which can be used directly to the physical memory. Faster than the other memory address, too many bits are needed to specify the address for large physical memory space. In this, the representation is like direct addressing mode. The effective address will be IR of the address, or if we talk about their syntax, it will represent as in accumulator, move in accumulator 200, right? So what it means here, in accumulator directly 200 will store. That is the value of operand, not address, right? And we will also understand when we will take the example of all the addressing mode at the end of this video lecture. And what is indirect addressing mode? If we talk about indirect addressing mode, the address will define as like this. What it means here, or if we specify it into a RTL, that represent M of 200. The stack pointer will move to the memory location of 200, and the A store the value that is stored at a 200. For example, it is 10. Then the value stored in a accumulator will be 10, and 200 will be the effective address if we are using indirect addressing mode. Likewise, relative addressing mode. Relative addressing mode have syntax that consists PC plus ADRS, or if we talk, that is instruction register address. That is in simple, if we talk about, that is address, and if we talk about technically, that is instruction address that specify in a stack location, or that will be given in a numerical if you talk in numerical. So, the sum of PC plus address will give the relative address. So, for example, if PC is 200 and address is specified 500, then the effective address of relative addressing mode will be 700, and the content may be of any that is stored at a 700 location. What is index addressing mode? It consists XR index register value plus ADRS. What is ADRS? Address register. So, as I said earlier, it is instruction register address that is specified in a stack or in a numerical. So, if we talk about here, if XR is 100 and ADRS, if we take the same value 500, then it will be effective address will be 600 and content may be any that is stored at 600 location. If we talk about base register, what is base register? That is AR plus, that is BR plus ADRS. For example, the value of base register is 50 and ADRS that will remain same 500 and the effective address like 550. So, that is the basic difference, and these are the indirect addressing modes. As I said in the first slide, there are two methods, direct and indirect. And indirect, we are using some simple mathematical calculation to get the effective address. So, in first case, effective address is 700, that's depend on the value of PC program counter. The second, index register, the value is based on the index register location, and in third, the final effective address based on the value of base register. If we see in this example, the effective address of all these addressing mode are different, but the address register is same. So, that is the basic difference between different addressing mode methods. What is implied mode? In implied mode, generally used when the source and destination register are same, and in this method the complement of accumulator is done, right? And in immediate addressing mode, we are using hash symbol before any address that also represent the value. For example, if we write 350 LDA, so it means load 350 into a accumulator, that is value, or we can say operand, not address. Clear? Likewise, in register mode, we study register mode in different numericals or in different methods. For example, R1 store the value of, if we talk about say 500, that is the effective address. So, R1 will store the value that is stored at a 500, it may be 20. Or if we talk about indirect register mode, that is the next one, I think. In indirect registering mode, if we see, if we write like that, R1 tends to or we also write it into M of and if we apply here board mass, we first solve this bracket. The value, for example, at 500 there is a 800 and at 800 there is a value of 20. So, R1 will store here 20, that is a indirect register addressing mode, and previous one is a direct addressing mode. In there is a effective address. Auto increment and auto decrement mode generally used when we stored or retrieve the value to move the stack pointer from one location to the next location. Generally increment the value. Same as the register indirect mode. When the address in the register is used to access memory, value in the register is incremented or decremented by 1 after or before the execution of the instruction. As I said earlier, what is implied mode? It is a complement of accumulator that is generally used when the source and destination of the operand is same. Here is an example that will give a detailed overview how addressing mode is derived by different methods and what is the role of effective address and how it's work. Here we see there is a address, I called many times it is ADRS. What is the value of ADRS? That is 500. If we talk about direct addressing mode, I told you earlier, effective address will be 500 and the content at 500, that is 800. In a indirect addressing mode, 800, that is double bracket as you see here, we specify 500 and that solve at a 500 it will come 800 and at 800 there is a 300. So the effective address will be 800 because that is solved twice. First the pointer will go to the 500 and at 500 the value stored, that is not the content, that is also the address of the operand, and then it will go to the 800, then finally value is 300. In relative addressing mode, I told in previous slide that PC plus ADRS. What is PC? That's will define in a numerical, or if we talk about the addressing mode, that represent to the current instruction. So the value of the next instruction point out 202. These first two addresses used to store the address and load to accumulator and define their mode. So the value of PC will be 202, where next instruction is mentioned in a stack. So the value effective address will be 202 plus 500, that is 700, right? And in a index addressing mode, I told earlier that will store XR plus ADRS. What is XR here? That is mentioned in a numerical, that is 100 plus 500. So the effective address will be 600. Go to the 600, the content is 900. Likewise, in a register indirect mode, addressing mode, accumulator will store R1, whatever the value of R1 is 400. What is stored at 400? That is 700. Right? So if we see, there are only two modes. One is immediate addressing mode and register mode that don't have any effective address. That is a generally viva questions. The addressing mode which don't contain effective address. There are two modes, effective addressing mode and register addressing mode. Register indirect addressing mode consists the address. Likewise, auto increment and auto decrement I discussed in a previous slide, that is generally used when we retrieve or store the value into a stack. It auto increment when we store any value into a stack, or it auto decrement when we retrieve the value from the stack. So hopefully that is clear to the all viewers about addressing mode, what is the addressing mode, their types and their syntax. So thank you. We will meet again in a next video lecture with the topic of different instruction format. Thank you.